Okay, this video is about determining whether or not a given function is a power function. Okay, so first of all, what is a power function? A power function is any function that we can express like this, right here. It's any function that we can express as k times x to the p, where k and p are numbers. So k is called the constant, usually, out front, and p is called the power. Okay, and the important thing to notice is that it doesn't have to look like this straight away. A power function is anything that can be expressed like this. So we're going to learn this by doing some examples, and these examples are numbered this way because that's how they're numbered in the book. These are problems from section 1.9. Okay, so first of all, number one, is this a power function? And by the way, it's not a bad idea if you want to pause between these examples and see if you can get the answers yourself. It's a great idea. But so back to number one. So is this a power function? Is 5 square root x a power function? The answer is yes. And the reason behind that is that, well, 5 square root x is no different from 5 times x to the 1/2. This is a common way in math of writing a square root as x to the power 1/2. And so now it's apparent that this is a power function because 5 is the constant. So k equals 5. And the power p equals 1/2. Okay, so on to example 2. It turns out, again, the answer is yes. This is a power function. And how do we convince ourselves of that? Well, one rule of doing algebra with fractions is that any number or variable can always switch from the denominator to the numerator or vice versa by taking a negative, taking a minus sign on its power. So what do I mean by that in this case? What I mean is that this is the same as 3 times x to the minus 2. Okay, notice the x moved from denominator to numerator, and so its power 2 took on a minus. And so now this does look like a power function with k equals 3 and p equals minus 2. Okay, number 3. Is this a power function? Is there any way that we can express this as k times x to the p, where k and p are constant numbers? Turns out the answer is no in this case. This is not a power function. Now, why is that the case? The reason that this is not a power function is that here, in the base, we have a number, and the independent variable x is in the exponent, which is not how it is here. Here, the independent variable is supposed to be in the base, and the exponent, or the power, is supposed to be constant. And we have the opposite here. It turns out this is actually called an exponential function, but more on that later. So number 3, the answer is no, it's not a power function. What about number 5? Is number 5 a power function? It turns out the answer is yes, and it's perhaps not obvious at first because we have 2 powers up here and we have this parenthesis. It's not quite written like k times x to the p, but one of the rules of algebra is that whenever you have a product, 3 times x to the 5th, to a power, the power is 2, you can take the product of the powers. What does that mean? It means that this is the same as 3 to the 2 times x to the 5 to the 2. Okay, and how can we simplify that further? Well, 3 to the 2, 3 squared is 9. And what is x to the 5 to the 2? Well, when we have a power to power, we take the product of the powers. So this is x to the 5 times 2, which is x to the 10. So in this case, our constant k is 9, and our power p is 10. Okay, a couple more. What about number 6? You might be able to infer from a couple of examples we've just done that this is a power function. And why is that? Well, first of all, x, the square root of x is no different, just like in example 1, from x to the 1/2. So step 1, you might say, is we can write this as 5 over 2 times x to the 1/2. 2x to the 1/2. Okay, and just like in example 2, if I want to move something from the denominator to the numerator, or vice versa for that matter, the power just has to take a negative sign. So I'm not going to move this right to the numerator for reasons of clarity. I'm just going to move it out front. It's the same thing. So in other words, this can be written as 5/2 times x to the -1/2. And now we can see that this is a power function. K, in this case our constant, is 5/2, or 2.5 if you prefer. And P, the power, is -1/2. Alright, one more example. Number 11. Is number 11 a power function? It turns out the answer is no in this case. You might be able to say that 11 is the sum of two power functions because 3x squared by itself is a power function. The constant is 3 and the power is 2. Even the constant 4 by itself, you could think of this as a power function. You could think of this as 4 times x to the 0, right? Because anything to the 0 is always 1. But if you put them together, you can't. If you add them, what I mean is if you add them, you can't write them as k times x to the p. So the answer is no in this case. This is not a power function. It turns out that it's a polynomial function, but more on that later. And that's it for this video. So that's how you determine whether or not a function is a power function.